Hi, welcome back. Welcome to Unacademy. Unacademy is the India's largest online learning platform. So once again, I am welcoming you all to this beautiful online learning platform. Now we are happy to announce that Unacademy is going to providing online training for GATE and engineering service exams. About myself, I G Venkata. I have 16 plus years of teaching experience. So far I mentored more than 60,000 students for GATE exam. At present, I am pursuing PhD from JNTU Kakinada and my specialization is VLSI design. Now here we check how to get Unacademy learning app into our device. Just go to Play Store in your device, type Unacademy in that. By typing Unacademy, it will load the Unacademy learning app like this. By clicking on this install button, it will install the Unacademy learning app into your device. Now what you will get, so by joining Unacademy, what you are going to be getting, first and foremost thing is you are going to be getting you have a daily live classes, next structured courses, live tests and quizzes, and unlimited access. See, daily live class, every day you have a live class. So because of everyday live class, you are continuously in touch with the subject. Now in this, you can continuously chat with your educator and you can engage the discussions, ask your doubts and answer polls. So these are the things you can perform while class is going on. Okay, and structured courses, whatever the course you have, so all our courses are structured in line with your exam syllabus to help you best to prepare for it. And live tests and quizzes, here evaluate your preparation with our regular mock tests and quizzes and get detailed analysis on your performance. Unlimited access, once you're taking the subscription, okay, you can access to all our live and recorded courses to watch from the comfort of any of your device. These are the benefits you get by joining Unacademy. Okay, here we have two subscriptions, iconic subscription and plus subscription. So in plus subscription, what are the things just before I mentioned? Daily live classes, structured courses, and live tests and quizzes. Finally, unlimited access. You get all these things in plus subscription. Okay, and after that, we go to check iconic subscription. In iconic subscription, we are providing a personal coach to you. So from that personal coach is going to guide you. You can get the guidance from top exam experts. He is acting as a personal coach to you. Okay, and you can align your preparation strategy and learning resources. That means once you've written some exam, he analyze that and he provide sufficient material to you and proper study planner also to you, study tracker. You can regularly you can get the reviews about your progress from your personal coach and mains question and answer. So in ESE, for engineering service exams, you need to answer a mains question. So you can practice mains questions regularly and your question is evaluated and personalized feedback is provided to you. These are the additional benefits you get in iconic subscription with respect to plus subscriber. So whatever the benefits getting the plus subscriber, you get all these benefits in iconic plan. In addition to this, you are getting all this. Now just before we complete previous sessions, all amplifiers, in amplifier analysis we use the H parameter. Okay, now just we go and do little bit analysis on H parameter. Okay, now So for whatever the analysis we use, that is called exact model analysis. Okay, so this is the CEH parameter model. First I am writing CEH parameter model. CE common emitter H parameter model. So it is like this. So common emitter, it is emitter, input is base, output is collector, it is IC, it is IB, input voltage VBE, output voltage VCE. So here it is HIE, HRE VCE, HFE IB, and it is 1 by HOE. Now the equations we are writing is VBE equals to HIE into IB plus HRE into VCE. Similarly, IC is HFE into IB plus HOE into VCE. This is called exact model. Exact model. Exact model. Why we are calling this is exact model is exactly, for if it is 2.002, we are representing it as 2.002 itself. What is the approximation of that? 2. Instead of 2.002, if you are representing it as a 2, then that is approximate model. Okay. Now, why are you not giving priority to this? Practical applications, we are not giving priority to this. Why? Because, see this. Actually, practically what happens is, in practical cases, once let us take your amplifier. This is my amplifier. Input, output and common terminal. Here applying input. Let us, I given this signal like this. Immediately what happens is it is going to be sampled. This signal is going to be sampled. Let us take sampling rate 2000 samples per second. Let us sample rate. Sampling rate 2000 samples per second. Samples per second. Let us assume. Now, at input side, you need to calculate VBE. Your VBE is HIE into IB plus HRE into VCE. At output side, IC is HFE into IB plus HOE into VCE. Practically what happens is, for every value of where every individual sample, it is calculating input voltage. To get input voltage, you need to go for one multiplication, second multiplication, and third one is addition. 3 calculations it has to perform. Similarly, at output side also it has to calculate 3 computations. Total 6 calculations. So 6 calculations has to perform for each sample. So total now 6 calculations. So 2000 samples per second into 6 calculations per each sample. Okay, and at the same time, for this amplifier I am going to giving plus VCC supply. Now for plus VCC supply, here there is a small change in supply voltage. You can't give any guarantee it is exactly 12 volts, 12.0001 or 11.999 something. So it is going to take different corners of supply voltage. That means VCC plus a small value minus a small value. That means for plus VCC it will calculate, for VCC plus it will calculate, for VCC minus also it will calculate. So that is, let us take 3 calculations. For each sample it has to perform like this. Okay, now it is 36,000 calculations worst case per second. 36 calculations it has to perform per second. See this. Okay, if sampling rate is increasing, 2000 samples per second is a very not that much efficient one. Practically you are taking 5000 samples, 10,000 samples, like that. In that case, number of calculations are going to be increasing. Okay, once the number of calculations are increasing, your device is taking more time to compute the output data, because it has to perform more number of calculations. So it is computing, for that computation it takes more time. Okay, more number of calculations. Because of more number of calculations per second, it is unable to calculate sometimes properly. These are the some little bit modifications little bit problems take place in the amplifier. Now we go and check, is there any possibility to reduce number of calculations? We check it. Okay, now for that I am taking the regular amplifier for better understanding purpose. And one more, here for my analysis purpose I am going to using typical H parameter values. Typical H parameter values are typical CEH parameter values. CEH parameter values. Typical CEH parameter values. Okay, now we are going to check the typical H parameter values. Now, so typical H parameter values are HIE input impedance is 1.1 kilo ohm. HFE forward current gain is 50. HRE reverse voltage gain is 2.5 into 10 power minus 4. Sorry, HFE, HRE both are gains, that's why no units, unitless. HOE is 1 by 40 kilo ohms, which is 25 microsiemens. Okay, these are the typical H parameter values. Just keep it. Next. Next one is okay. Now here I am taking now amplifier, that to CE amplifier. CE amplifier it is. Now this is, let us take it is input impedance of the amplifier is Ri. This is the input voltage VBE, base to emitter voltage, and here is your RS. Vs. Okay. Now from H parameter, parameters, we can write VBE is HIE into IB plus HRE into VCE. Now I am taking, let I am giving 100 millivolts at input. In that 20 millivolts drop across RS and 80 millivolts presented as a VBE. And due to the gain of this at output, I got VCE value. Let us take that VCE is 1 volt or 2 volts. You can take, it's not an issue. 2 volts. Let not more than that. You did not get more than that for 80 millivolts. Now I am going to applying this approximate values I am going to be using here. Now see this. VBE is, you are saying it as 80 millivolts. Okay, I am using that. It is 80 millivolts is equals to HIE into IB plus HRE value. I am using this. HRE value is 2.5 into 10 power minus 4 into 2 volts. So 2.5 into 2 is 5 into 10 power minus 4. So it means plus 0.5 millivolts equals to, this is the HIE into IB. Here is you have 80 millivolts. 80 millivolts. Now from that, the value of this one is, the value of this HIE into IB is 80 minus 0.5, 79.5 millivolts. So 79.5 millivolts is much greater than 0.5 millivolts. Okay, and you can write 79.5 millivolts is approximately 80 millivolts. That's what I am doing. So whatever the value of this HRE into VCE we have, that HRE into VCE is very much less than HIE into IB. HIE into IB. That's why I am going to be neglecting that. By neglecting this, compared to this, it is very small. We can neglect it. By neglecting that, what is the benefit to me? Now, my benefit is only I need to calculate VBE is HIE into IB. Only one calculation, one computation. Now, if you go in previous case, at input side 3 computations you are doing. Instead of 3, I go for only one calculation. Now it became, instead of 1, from input side 1, output side 1, only, sorry, it is going to be only 2 calculations. Now see this, how many times it is decreasing. Okay, so once number of calculations is decreasing, your device gives early response. Okay, so because of getting fast response of the device, you are going to be, instead of applying exact model, we are going to applying the approximate model. That means we are taking the approximate value, not much variation. You may ask one thing, sir, for example, in an IC I am using 1 lakh transistors. From each transistor I am going to neglecting zero point 0.5 millivolts. Okay, now 0.5 into 1 lakh, it is a very huge value. Then what is the reflection? Where it is going to be reflecting? See, my dear student, here we are going to practically you are going to designing digital system finally. You are using a CMOS technology, most of the cases, default technology. In CMOS technology, see, not only this, in any technology, we are going to applying digital system, designing digital system. In that, zero logic representing some voltage, 0 to 1.5. For example, in case of CMOS, if you take the CMOS technology, in that case, logic 0 in this sense, a voltage of in between 0 to 1.5 volts is considered as a logic 0, and logic 1 means it is 3.5 volts to 5 volts. 3.5 to 5 volts is considered as a logic 1. Okay, logic 0 and it is logic 1. So even though 0.05 volts, 0.5 volts, 0.5 millivolts variation, that won't affect. Due to that, instead of staying your value somewhere here, it may move little bit more. That's it. Even though it is moving little bit, no change in the logic. Okay, so that is the variation. So finally, from input, what we mentioned, from input we can write simply VBE is approximately HIE into IB. Similarly, we can write IC is H of E into IB, because this H of E into IB is much greater than HOE into VCE. Okay, we go and do this analysis also. See this, I will show that one now. So your equation is IC is H of E into IB plus HOE into VCE. Now let I am taking IC is 5 milliamperes. Okay, now it is 5 milliamperes. So it is something plus HOE value, we know that it is 1 by 40 kilo ohms into VCE 2 volts we taken. Now it is 5 milliamperes. So it is 220 times 1 by 20, 0.05 milliamperes it is. Now the value of this H of E into IB is 5 minus 0.05, 4.95 milliamperes. Therefore, H of E into IB is much greater than HOE into VCE. Because of that, I am taking IC is approximately H of E into IB. This is called approximate model. Therefore, the approximate model is approximate model is model of transistor the approximate H parameter model of H parameter model of transistor is see this is your exact model. This is your exact model. So this is IC. HFE into IB, HRE into VCE, HIE, emitter, base. This is IB, VB. Now in approximate, this is our exact. In approximate, what you done? HRE, VCE, you taken 0. It is short circuited and it is open circuited. It is open circuited. Okay, no current through this. Current through this one is 0 amperes. Now it is simply like this. It is common emitter, base, HIE, IB, collector, IC, HFE into IB. So this is VBE, it is VCE. That's it. And the advantage of this one is, by switching from approximate to exact, while analyzing CC and CB amplifiers, everything we got in terms of CB amplifier H parameters and CC amplifier H parameters, you need to convert that CB amplifier H parameters into a CE H parameters and CC also in terms of CA. You need to use, because we know only common emitter H parameters. We don't know the remaining common base, common collector H parameters. We don't know that. You need to go for that conversion. Instead of going to that conversion, by using this one as a transistor, that means instead of replacing transistor CB model in common emitter, common collector H parameter, common base H parameter, we replace your transistor by this circuit like this. Now I am defining finally transistor is like this in approximate. Emitter, base, collector. HFE into IB, HIE. This is IB. That's it. This is the approximate model representation of transistor. Okay. Approximate model representation of transistor. Okay, and this is a emitter current. This is collector current. Now you can replace this one in any amplifier, CE, CB, CC, wherever you can replace it. Directly you get the values. No need to do any conversion. Now you may ask one thing, sir, we are using H parameter, okay, what are the benefits? Why we are going to H parameter? Now I am going to representing that. First, benefits of H parameter. First one is, they are real numbers at audio frequency. They are real numbers at audio frequency. Second one is, it is easy to measure. We can easily measure that. Easy to measure. Third one is, we can obtain these parameters from static characteristics of the transistor. Okay, it can be obtained from Transistor static characteristics. Manufacturers. Yes. Specify the H parameters. Okay. These are the benefits of H parameters. And at the same time, we don't know the common base, common emit, common collector H parameters. Already I mentioned the typical common emitter H parameters. Okay. Now I'm going to representing the conversion. If you want common base H parameters or common collector H parameters, you have to get those things from known common emitter H parameters. So now I'm writing that conversion formulas. Okay, conversion formulas. See, now here I am converting common base to common emitter relation, and here common collector to common emitter. See, for common base, first HIB, next HRB, HFB, and HOB. For HIB, HIE by 1 plus HFE, HFB minus HFE by 1 plus HFE, HOB is HOE by 1 plus HFE. Simple. But for HRB it is HFE into HOE by 1 plus HFE minus HRE. Simple. Now CC conversion is very easy, simple. HIC is HIE and HRC is 1 minus HRE. So 1 minus HRE value, we know that 2.5 into 10 power minus 4. It means 1 minus 0.00025. So approximately 1 it is. Next, HFC is minus of 1 plus HFE and HOC is HOE. These are the conversion formulas from one H parameter to another H parameter. You may expect these formulas also directly. Okay. See, now, see here are the top educators from Unacademy. Few of the top educators. Tiwari sir, he is IIT topper. He has 7 years of GATE and ESE teaching experience. And Ankit Goyal sir, he obtained All India first rank twice in GATE Electrical and he was awarded President of India Gold Medal in IIT Indore. Next, Sanchit Jain sir, he is the Computer Science faculty. He has more than 8 years of teaching experience. Jaspal Singh sir, he is the ex-IAS officer. He got 4th rank in IAS and he is the ex-senior faculty from GATE ESE. Here are the few more top educators from Unacademy. These are the different engineering service exams, GATE and engineering service branches available in Unacademy. ECE, chemical, mechanical, computer science and information technology, instrumentation engineering, electrical engineering, civil engineering, production and industrial engineering. Now, there are 2 subscriptions, Plus and Iconic. Plus Plan and Iconic Plan. In Plus Plan, India's best educators are handling your subjects. Interactive live classes are there, structured courses and PDFs, live tests and quizzes. Here also you get the same thing. But here is the difference we are showing. Once you written a exam, it was forwarded to your personal coach. You do the personalized test analysis on that. prepare a study planner, and respect to study material also they will forward to you. And plus plan is available in different subscriptions: 1 month, 3 months, 6 months, 1 year, 1.5 and 2 years. For 1 year it is a 30,250. By using my code VROUT10 during subscription, you get it by 10% discount. And the beauty is here EMI option also available. And next we go to Iconic plan. It is available in 2 subscriptions, 1 year and 2 years. For 1 year it is 50,250, and by using my code VROUT10 during subscription, you get it by 10% discount. After discount it became 45,225. Here also EMI option is available. Thank you very much. Thanks for spending your valuable time with us, and don't forget to use my code VROUT10 during subscription. Hit the bell icon for getting notifications, and if you like this video, don't forget to subscribe and join our Telegram group for getting latest updates on our upcoming videos. Please give your valuable comments on YouTube. Thank you very much. Thanks for spending your valuable time with us, and once again I am thanking Unacademy to providing such a beautiful facility to us.